Okay boys, we're going to have a look at exercise 1 on page 51 now. If you haven't already done so, can you please make sure you've read through the examples on page 50 and 51 where it clearly explains how to find the horizontal and vertical components of an angled vector. So in this case here, a simply supported beam, roller support, pin support, but we've got three forces coming down at angles. Now to solve these we'll need to know the vertical and horizontal component of each. We can see there that 11 kilonewton force has vertical and horizontal components, as does the 14 and the 8. Be aware that the vertical component in the 11 is going up, these two going down, and the horizontal component in each of the three forces going to the right. So the first thing we can do is get the values for our vertical and horizontal components. So that's simply completed by, you can see here I've set up a little grid, 11 kilonewtons, the 14 and the 8. I'm going to write down the horizontal and vertical values. So force vertical is equal to 11 times sine 45, which is equal to 7.78 kilonewtons. Force horizontal is equal to 11 times cos 45, and we know that that will be the same as the 45-degree triangle. The 14 kilonewton force vertical is equal to 14 times sine 30, which equals 7 kilonewtons, and the force horizontal 14 times cos 30, which gives us a value of 12.12. And finally our 8 kilonewton angled force vertical, 8 times sine 60 is equal to 6.93, and horizontal component is 8 times cos 60, giving us a value of 4 kilonewtons. So there we have our horizontal and vertical components clearly identified. We can see by the vectors that I've put on which direction they go, up, down, down, and to the right. So now, like all of our simply supported beams, the first step we need to do is solve the moments about the right hand support. That will give us the reaction at A. I always like to get the reaction at the roller support, as I know that it's going to be a vertical reaction. Don't forget, boys, that we do have our reactions that are RL, and here we have a reaction that is going to have a vertical and horizontal component at the pin joint. We can call that R for right, X, and Y. Eventually that will make up some sort of angle in there and give us the final value of RR. We'll be able to work out that from the resultant of these two, and also find the angle theta using tan theta. So like I said, we can start with doing the sum of the moments about B. So I always have a positive value. Sum of the moments about B is equal to 0, and then we can do all the moments that we can see there. First one we look at, 6 kilonewtons, vertical component, vertical, as well as the RL. So the effect that 6 has on point B is spinning in the anti-clockwise direction. It's coming down there, trying to spin around B. So that will be -6 times 4 and 4 is 8 and 3 is 11. Plus, this is going in the opposite direction, so it'll have a positive effect of 7.78. I get these numbers up from up here. 7.78 times 8 plus, going back, spinning anti-clockwise, so a negative value there of 7 times 4 plus this one here is spinning clockwise around B, so it's a positive value, 6.93 times 1 meter. And finally, our last unknown is RL, spinning clockwise, so it's a positive value of RL times 11 equals 0. Remember, perpendicular distance back to the point of application. So we transpose that equation now. We find that RL is equal to 2.26 kilonewtons. And it's a positive value, so it means it is going up. So that's a reaction there. RL is equal to 2.26 kilonewtons going up. The next step is that we need to find our vertical and horizontal component of RR. To do that, we can simply use the sum of the vertical forces and sum of the horizontal forces. So sum of the forces vertical, anything going up is positive, is equal to 0. So let's have a look at them all. First one we come to is -6, positive 2.26 plus vertical component of the 11, 7.78, minus vertical component of the 14, 7, minus the vertical component of the 8, 6.93, and then we've got the unknown value of RR, y component, so that's plus, it's going up, we think it's going up, RR, y is equal to 0. Transpose that equation, we end up with RRY is equal to 9.89. And as it's a positive value, it stays in the sense that we gave it of going up. Next stage is to have a look at the horizontal components. So sum of the forces horizontal, we're going to say anything moving to the right is positive, is equal to 0. So horizontal components, this time we're dealing with our horizontal components and our unknown. We've got 3 horizontal components from our cos calculations. So we can say that those 3 are positive and that one would be negative. 7.78 plus 12.12 plus 4 minus RRX is equal to 0. Therefore, negative RRX is equal to negative 23.9. So RRX is equal to 23.9. Being in a positive direction means that that arrow stays the same. same sense as what we gave it to start with. So what we've done there is identified the vertical and the horizontal component of this reaction RR. It's our task now to go and find what that value is and its angle. You can use some simple maths for that one. So if we've got a right angled triangle, we'll end up using a squared plus b squared equals c squared. If I draw the triangle that I'm looking for, up here in this section, we've got a vertical component worth 9.89. You can see that from that value there. And horizontal component, okay, joining head to tail, that is worth 23.9, and you can see that down here, the bottom left hand corner, 23.9. And then if I was to find a resultant of those two vectors, join head back to tail, and remember that the arrow goes in the opposite direction when we're working with a resultant, and we can say that is RR. We need to define the angle as well. We can pick any angle we want, and we could say that is theta and work that out. So using a squared plus b squared equals c squared, we can say RR is equal to square root of 23.9 squared plus 9.89 squared gives me a value of 25.87 kilonewtons. So that's the value of the hypotenuse, which is RR, which is that reaction there. So now we just need to define with all vectors point of application, the sense, its magnitude, and also its angle. So finally we do the angle. We've got angle theta opposite over adjacent, tan theta opposite over adjacent. Will let me find that. So tan theta is equal to opposite of 23.9 over adjacent of 9.89. Therefore theta is equal to inverse tan times 23.9 over 9.89 gives me a value of 22 degrees. There's theta in there, the value of 25.87 kilonewtons. So from that, guys, you can see that we've clearly solved the reactions at the supports. We've got our roller support, can only be a vertical reaction, and we've got a pin support that can have both vertical and horizontal components, therefore an angled reaction.